Welcome to the Penn State Horticultural Research Center here at Rock Spring. My name is Francesco Di Gioia. I am an assistant professor of vegetable crop science in the Department of Plant Science at Penn State. And today I would like to show you some of the research that we are doing here in a structure that we call high tunnel. It's a very nice structure where we have um, almost full control of the environment, meaning that we have an automated ventilation system. And this is a type of structure that growers in Pennsylvania and the Mid-Atlantic region are using more and more often to protect their crop, to have higher yield and like more sustainable production system, resilient to like changing environment and changing weather condition. And in this particular study, um, this is a research funded by a Specialty Crop Research Initiative program funded by the USDA in collaboration with partners from different states in the US. It's a big project, and we're looking at the potential of using grafted tomato plants versus non-grafted tomato plants, and also at their response to different input, different levels of nitrogen fertilizer. So we have plots that are non-fertilizer all the way to plots that are over-fertilized to understand the response of these two different type of plants to nitrogen and what should be the optimal level of fertilization. And while we are doing that, we are using different tools to monitor what is happening in the soil and also at the plant level. And of course, in this project, there is also the collaboration, the contribution, the support of the Pennsylvania Vegetable Grower Association. And even this structure was fruit of a donation from PVGA, a company that does this type of structure, remote greenhouse, and the College of Ag at Penn State. And we are trying to use it as much as possible to really serve, the need of the growers in Pennsylvania and the Mid-Atlantic region.
And basically what a suction lysimeter is a plastic tube with a ceramic tip that is porous and permeable, and we will put this in suction, where we'll take the air out, and the water will go through this porous tip, and we'll be able to test that water. So what we would do is after we fertigate, we'd wait a couple hours, allow the plants to take up some of the fertilizer, and then we would set this soil lysimeter by taking this pump, and we have the soil lysimeter open, and we would pump the air out of the soil lysimeter or the suction lysimeter up to 70, 60, 70 psi, and then you close here. So now the suction lysimeter should be in suction, and it'll start pulling the water from the soil at 10 inches deep. After this, we give it a few hours. We're coming back the next day, and there should be a water solution with the fertilizer in it, and we would come back and with a syringe just take that out. So it's very easy. We would open this up first and then connect this and pull the water out, and you immediately have the water ready for test, and that should be the water that is available to the roots.
So this is a company that sells these data logger that are connected to soil moisture sensors that we use to manage the irrigation. So while we are doing this type of research, we need to kind of guarantee that, except the nitrogen level and the grafted versus non-grafted plants, everything else is managed to the optimal level. So we are using a lot of technology for that. And one of the things is how to manage well the irrigation. We are using soil moisture sensor so that we put again in the root zone. And through this data logger, we are able to monitor what is happening even from home, because this is communicating to a cloud service where we see the status of the soil moisture, and then based on that we decide, okay, today we need to irrigate because we reached a certain threshold and we don't want to pass, we don't want to go over that, and so that helps us to manage in a good way the irrigation to avoid that we have any water stress. This is similar technology, but here we are measuring air temperature, relative humidity, and then on top here we have a sensor that is measuring the radiation. In particular, is measuring the photosynthetically active radiation. So not the entire spectrum of the solar radiation, but just the portion that the plants use to do photosynthesis. And that is important for the plant, for for the plant growth and for the plant physiology. Measuring what is happening here and recording all the data, we are able to say, if the environment affected our crop, but also that give us the opportunity to model all the parameters that we are doing over the weather, the climatic condition, the environmental conditions. And so then we can develop technology like the decision support system, and some of that we are using already in the open field and that we want to develop for this type of structure, this type of production system. We have 4 different levels of nitrogen. So we call them N0, N1, N2, and N3. N0 does not have any fertilizer. N3 has 300 pounds per acre of nitrogen fertilizer. And here we have, so this is, for example, N1, which is so the lower, one of the lowest level of nitrogen, and this is a grafted plant. You can see here some sign of nitrogen deficiency and also iron deficiency. But this is pretty good green and has a lot of biomass. Then next to it, we have a plot with non-grafted plants. And you can tell the biomass, the leaf biomass is lower, the plant is shorter. And so we are comparing side by side these two. But then going down here, we have other nitrogen levels. So this is the non-fertilized plot. So we have this to show the growers, if you don't fertilize with nitrogen, what type of plant do you get? So this is again non-grafted, and then you can see the N0, so no fertilization, but with the grafted plant. Because the grafted plants have a higher root biomass, they are able to seek, to reach more resources in the soil. And so potentially they may suffer less the nitrogen deficiency. But still you can see the light color, the light green color here. And then as we move on this plot, this is, for example, what we have as the maximum rate, so 300 pounds per acre of nitrogen. And you can tell the color of the leaves is much more greener, dark greener, and it has some more light to it. And so this is an ungrafted plant, and you can see the biomass of it and all the leafage. And this is instead grafted plant with the same level of nitrogen. And then down the road we have what is N2, so the second highest level of nitrogen with non-grafted plants and with the grafted plants at the end here. So you can tell from the leaf biomass and the height that there is some difference there between the two type of plants. So the rootstock, it has an effect, the root system. What we are trying to do is to kind of model what will be the take-up, the plant growth and the take-up of nutrients. And then at the end, we will be able to say, okay, the optimal rate for this environment under this condition is like this. And that will provide a suggestion to the growers of how much they need to fertilize without, polluting the environment and without, losing any yield or things like that.